Hello everyone. In this video, we will work with integrals of transcendental functions. These transcendental functions involving the natural logarithm of x. And you see that we are working with definite integral right here, so we have to apply fundamental theorem. There's quite a few rules that we need to apply to this integration. The first thing I would like to do is to break this expression into two fractions. So I will write it as the integral from 1 to e 2 divided by x plus 3 ln x divided by x, all of it as the integrand with the differential factor dx. So after you break this into two fractions, you should apply the properties of integration. That means you can integrate this part of the integrand, and then you integrate this part of the integrand. That means you can break this into two integrals. So let's go back and review the formulas for the integration. Okay, so formula for integration, I can quickly show everyone that we have worked with formulas before. So we have integration formulae, definitions, and theorems. Okay. So when we integrate, so this is the very basic rule. When you integrate, this is the integral of a sum or difference of two more functions. Then what you do, as you see, you can break this into individual integrals to work with. And if you have a constant multiplied by an integrand, you can bring that constant across the integral sign. Okay, and another formulas I would like to review to everyone is a definite integral. That means you have to apply the fundamental theorem. Okay, so you evaluate the result from the upper limit and you subtract the result, evaluate from the lower limit. Okay, also I would like to remind everyone of these formulas right here. Okay, so if you have the integral that raised to the exponent minus 1, the result will be ln of u. So let's take a look at the formula sheet that I provided to everyone. So on this formula sheet, I am giving everyone the formulas involving transcendental functions. Okay, so why taking the integral of transcendental function, we follows all of these formulas. So what you do is you need to take a look at what type of integrand is given to you, and then you go to this formula sheet to see if any formulas that apply to the integrand that you are working with. All right, okay, so you can see that I would like you to note these formulas right here, okay, and also try to find whether or not you can use any of these formulas. Okay, so far I see that this is the only one that we are going to use here. Okay, then you need to use a substitution method, okay, in order to integrate this integrand. So I can tell you that integration of transcendental function is quite complicated, and we have to develop some sort of strategy. So I have prepared some strategy here for everyone to examine, and there's no fast rule for this. So this is only a suggestion, and you develop this strategy, see which one is suitable for the integrand that you are working with. So right now, whatever step that I'm giving you is probably not clear at this point, because you have to do a few in order to recognize why I put all of this strategy together. Because when you integrate transcendental function, you need to analyze it and see which method will apply to you. All right, so first of all, I ask everyone to simplify the integrand if possible. Okay, so what we have done in our example here is we actually we simplified it, right? So we simplified it. We simplified it to 2 over x plus 3 ln x over x. The reason we did this because I can see that I can break this into 2 integrals, and I can apply the formulas for this one. Because I have x raised to the exponent of -1, this one will become a ln of x. So I can apply the formulas that I showed you earlier. So this formula is right here. All right. Okay. So let's go back and see what we have next. So for this one, I have 3 ln x over x dx. So if you go to your formula sheet, so what do you see? You go to your formula sheet, you will see that you say, okay, maybe I can use these formulas, maybe not. Okay, so you may be able to use this formula, you may not be able to use it. The reason for that is because take a look at the question that's given to you. The question given to you, there's an x down here. So what do we do with this x? So you have no choice, but you have to use the substitution method. Okay, so go back to the strategy that I show everyone. This one, I'm giving everyone as simplify the integrand if possible. So that's what we did, okay? We broke it into 2 integrals to work with. Then we look for an obvious substitution. So what does it mean by the substitution method here? Substitution method is you have to let a part of your integrand equal to u. So after you let it equal to u, you have to differentiate it because you want to pull out that differential factor du over dx. Then you can manipulate your equation to match the remaining expression of the integrand. Then you substitute. Okay, so if this 2 doesn't work, then what you need to do is you need to look for the trigonometric functions and match with the formulas what you can use with the formulas. If not, you have to use long division, completing the square, partial fraction, or integration by part. But all the example that I'm giving you in this video or the next video, I think the strategy number 1, strategy number 2, and perhaps 3A will apply to all of that. Okay, so step 3B to E or the strategy 3B to E are the complicated integrals, and we are not going to cover it in this video or the next few videos. Okay, so again, can I repeat this for everyone? Okay, so you simplify the integrand if possible. Okay, so you have to make sure that you apply the correct algebra in order to simplify. And then you look for the obvious substitution. Then we go from there. Okay, so let's concentrate on this 2. And then we have to do a few in order for you to figure out how to work with integration of the transcendental function. So because with integration, we have learned integration formulas is to raise the exponent. So you have to write your integrand as an exponent. Then you add 1 to the exponent, and then you divide it by the result of the exponent right here, right? So x raised exponent n, you add 1 to that, you divide it by n plus 1. Given that n is not equal to -1. So when n is equal to -1 in this case, so that means your result will be ln of u. So that means you use the formulas here. Okay, so if you have a function raised to a power, then you have to let that function equal to u. How do you get the du out of it? You have to differentiate u. Okay, so the relationship between du dx, you use that to substitute into your integrand to work with. And you also have to apply all of these formulas here. Okay, so the properties of integration, you can break the integrals into a few simple integrals so that you can integrate. So if you multiply the constant with a function, you can bring the constant across the integral sign, and you also have to apply the fundamental theorem if you work with definite integral. So the example that we are going to work with will involve all of these formulas that we have been working with. Okay, so you can see that the example that I'm going to work with here will involve all of these properties, also the substitution rule, also these formulas, and also involve fundamental theorem. Okay, so let's get back to this. So originally, I was saying that I break this into two, okay? Because I will apply the property of integrals right here. I will break this into two integrals, so then it's easier for me to integrate. So if you don't break this into two fractions like this, then it's a little bit complicated to integrate. Okay, so there isn't any formulas involving 2 plus like anything multiplied with a ln x, everything divided by x will have like a particular formulas for you to apply to this. All right, okay. So when I break this into two integrals, what I can do here is I have it like this. So integral from 1 to e of 2 over x dx, okay, plus integral evaluate from 1 to e of 3 ln x over x dx. Okay, so properties number 1 is to break this into two integrals to work with. So that in the way that I simplify my integrand, right? So this one I can apply the formulas, but before I can do that, see, you have to bring the constant across the integral sign. So right here you have dx over x. Over here you bring the 3 across the integral sign, so you have ln x over x dx. Okay, so at this point you are going to see what formulas apply to this. So we know right away the formulas applied to this would be ln of x, right? So ln of absolute value of x. So, but I will work with that in a minute. Before I write this solution down for everyone, I would like to ask everyone to pay attention to this. Okay. So again, there isn't any straight formulas to apply to this. You cannot apply the formulas integral of ln u du or ln x dx because you have an x as the denominator. So the only thing you can do here is to apply the substitution method. Okay, so substitution method means you have to let something equal to u. So what I'm going to do here is I'm going to integrate this part for everyone to see using substitution method. Okay, so I'm going to let u equal to ln of x. So you probably ask me why I am doing that. Why do I let u equal to ln of x? So another I don't want to say the method, but I just want you to think of the word analyzing. Okay, so you need to analyze your integral before you can integrate. If you know how to analyze your integrand, you already are halfway to your solution already. Okay, because while analyzing your integrand, you kind of figure out what method I'm going to use here. So I let u equal to ln x because I know that after I let something equal to u, I have to differentiate So that means I have to find du over dx. Okay, so write du over dx. Then the reason I let u equal to ln x is because now I'm going to show you the formula sheet again. Okay, so these two formula sheets, they go hand in hand, and I only show you part of this formula sheet. So I show you the integration of transcendental function, but in order for you to integrate, you need to know the derivative of transcendental function as well, because derivative is the reverse process of integration. Integration is the reverse process of derivative. So I let that equal to u because then I know that I can apply this formula. Derivative of a function, it will become 1 divided by that function. Okay, so in that way, I can take care of the dx over x. Okay, so let's go back to our okay, so you see right here, what I have is I have u equal to ln x. Du over dx will give me 1 over x. Okay, so I write 1 over x. So now, what you need to do is you need to manipulate this equation. Okay, you manipulate this equation because you are using a substitution rule. So you have to think that what do I want to substitute? So now you see this ln of x will become your u. Okay, but then you will have dx divided by x, right? So this one is dx divided by x. So dx divided by x, what do you substitute it with? So that means you need to manipulate this equation. So what I will do in this case is I will write du divided by 1, okay, equal to dx over x. So this is the substitution that you need to substitute in here. So now this one will become, so I will do this in a minute, okay, so 3, the integral from 1 to e, okay, so in this part you are writing ln of x. So let me rewrite this so it's clear for everyone. I will write ln of x times dx over x, right? So it's the same thing as you write ln x divided by x multiplied by dx. So it's the same thing as ln x times dx over x. So your dx over x, now this one is the same as that. You see, it is the same. Okay, so it's the same as that. So you want to substitute that with the du. So now it will be a du. So this will be a du, but you let u equal to ln x already. So in this case, what you have is you are having 3, 1 over e. Ln x is now your u. And your dx over x will be equal to du over 1. So in this case, I just put du. Right? Okay, so what is the integral of u du? You add 1 to the exponent, you divide it by the result. So in this case, what you have is you should have 3 times a half of u squared, okay, plus c. Okay, so let me write down what I have for this integral. So this one, I should have it as 2 ln of x. And this one, I should have 3 times 1 over 2 of u squared. Okay, so in this case, just let put C here before I apply my fundamental theorem. Before I apply my fundamental theorem, I will substitute the u back into this function u that I use the substitution. So 2 ln of x, okay, add that with 3 over 2 ln of x, all of it square. Okay, now I'm going to write evaluate from 1 to e. Okay, you see all the formulas, properties of logarithm apply to this question. So let me go over this one more time. Okay, and up to this point it's easy, right? So up to this point, all I have to do is just apply fundamental theorem in here to figure out my result. Okay, so let me go over this again. So for this question, what I have is, first of all, I will break this into two fractions, 2 over x, 3 ln of x dx. Then I can apply the formulas for this right away. Okay, so I know that this will become ln of x, 2 times ln of x. But for this part here, I cannot apply the formula of the transcendental function integral of ln x because I have an x as a denominator. So I have no choice but using the substitution method. So I will let u equal to ln x, differentiate that, I have 1 over x. Manipulate this ratio or this equation, I end up with du over dx over x. Why do I make that dx over x? Because I can substitute that in here as du. And the ln x has now become the u. So at this point, what you need to do is you have to apply the very basic rule for integration, which is add 1 to the exponent divided by the result. So here's u to exponent 1. I add 1 to that. Therefore, I divide it by 2. That means I multiply by a half. Okay, and then there's my exponent 2. Now apply fundamental theorem for this. I have 2 ln x plus 3 over 2 times ln x all of it square. Integrate, apply fundamental, evaluate from 1 to e as the lower limit to the upper limit. Okay, so we can quickly do that on this side. So what I have here is I can tell you that, so I just want to give myself some space. So what I will write is I will write 2 ln e, right? Okay, 2 ln e plus 3 over 2 ln of e, and this is all of it square. So this one here is my f of e. Okay, now I'm going to subtract this with my f of 1. Okay, so f of 1 would be 2 ln of 1 plus 3 over 2 ln of 1, all of it square. So this part here is my f of 1. Okay, so let's see what I have. So 2 ln of e, what is ln of e? Ln of e is equal to 1. So this part should be equal to 1. Okay, and ln e is also equal to 1. Okay, what is ln of 0? I mean ln of 1 is equal to 0. Okay, I thought of the number 0 before, and then I say it. So ln of 1 is equal to 0. Okay, so I should use the arrow here. Okay, so use the arrow. Okay, and then ln of 1 is also equal to 0. So now you see f of 1 is equal to 0. Therefore, so make this f of 1 equal to 0. So therefore, what I have next is it is equal to 2 times 1 plus 3 over 2 times 1. So in this case, I should have 2 plus 3 over 2. So the final answer is 7 over 2. Okay, all right. So one question, but we have to apply quite a few methods here in order to integrate. Okay, so I will continue with the next video. And in the next video, we are going to integrate a transcendental function involving the e. Okay, so again, I just want to remind everyone the strategy of integration. Okay, so whenever you integrate, you really need to look for simplify the integrand if possible. Okay, so that means you use algebraic manipulation, trigonometric identities, properties of logarithm, and simplify the integrand and make the method of integration obvious. Okay, so what is the method of integration? Is involving the all the formulae that I'm giving you on this piece of paper here. So I give you 2 pages for integration of transcendental function. Okay, so you have to look for what formulas is actually applied to your integrand. And don't forget, the reason I attach the derivative of transcendental function is derivative and integration, they work together. Because if you use substitution method, then you have to differentiate. Okay, you have to choose the correct u. You have to choose the correct u. What else that I should remind everyone? Okay, so don't forget to review the basic rule for integration. Its definition, its properties. Like you can break that into 2 or 3 integrals given the sum of the difference. Okay, this only works with the sum and the difference. And then if you have a constant multiplied by the integrand, you can bring that constant across the integral sign. And this basic formulas always apply. Add 1 to the exponent and then divided by the result. And then here is apply the fundamental theorem if you work with definite integral. So now we go back to the question that we work with. Okay, the question that we work with. Here, what I have is there isn't any fast rule how to apply to this. So what I need to do is I need to break this into 2 integrals, 2 fractions, because they have the same common, they have the common denominator of x. So you can write it into 2 fractions like this. This one obviously will be the ln, but this one you need to use substitution method. Okay, so using substitution method is to let u equal to, then differentiate, and then try to match your integrand dx. Now you are going to write that instead of writing dx, you are writing it as du. So ln x, you already let it equal to u. So now your integrand change into u times du. When u times du, it means that you can apply the formulas for integration, add 1 to the exponent divided by the result. After that, substitute the what you let u equal to back into this, so it becomes ln of x, and then apply the fundamental theorem. Okay, so it's just a simple question. This integrand appears to be so simple, but there's quite a few methods that we need to apply. All right, thank you.